The purpose of this video is to kind of just walk you through how to access the teacher implementation guide or the teacher's note in Carnegie. No matter what lessons you use, listen, no matter what material you end up using, even if it's not Carnegie, it's your own material, I think any teacher in the district or anywhere else can totally benefit from the teacher implementation guide that we have here. So how do we access it? So when you go to carnegie.com, you log in, it will take you to your geometry course, right? Or whatever course you are teaching, you will have your modules listed here. So for example, if you're working on module 2, then you click open module 2. Now I'm gonna walk you through a serious number of clicking. That's what's a video. You can always go back and see how I was able to get to a particular page. When you click on module 2, it will take you to topics. So in this particular case, module 2 has 3 topics. Now, how are you going to know which topic do you have? Well, you can just kind of just read through here. The topic 2 say justify line and angle relationship or blah, 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 right? Or you can look at a unit map. It will tell you in a curriculum document which unit and which topic to go click on. So let's say we're going to click on topic 2. You click on topic 2. After clicking on topic 2, your next thing is to find the lessons. You can click on lessons. If you wanted to see videos that we have here, there are some videos that shows you what, kind of giving an overview of what the content would be like from a student approach, okay? There's videos here, but right now I'm going to show you the teacher implementation guide. So you click on open the lessons. After you open the lessons are listed here. You have you can print lesson 1, or you can print lesson 2, or whatever many lessons in lesson 3. However, right now we're going to look at the teacher implementation guide for lesson 1. Lesson 1 is about proof positive. Now, or it doesn't seem so interesting. Let's say you want to do teacher implementation guide for lesson 2, which is a parallel universe, or teacher implementation guide ins and out implementation guide ins and out for lesson 3. Okay, I'm curious about implementation guide for lesson 1. Then you click on the PDF. Don't click open, click on PDF. Which one is it? This one right here. All right, here we go. This here for me, like I said, this is beneficial no matter what content you are teaching. This is helpful to just build a content knowledge, and then you can go from that. All right, so first it always starts with the lesson overview. It tells you in this lesson, student apply real numbers properties to angle measures, line segment, distance, all of that, right? And then it gives you the standard what this lesson is about. And then it gives you an essential idea of what's going to happen in this lesson. No, when I say lesson, through the entire lesson that you have here. You have addition properties of equality, subtraction properties of equality, and so on. And then the construction of proof, 2-column proof, flow chart, and so on. Kind of like an overarching idea as of what's going to happen in this lesson. All right, now we'll move to the lesson structure. Now, lesson structure, depending if you will use this lesson. If you're not going to use this lesson, which is okay to me, that's fine. But you can always kind of read and see, they're gauging for like 3 days with this, and then this what the engage would look like. That's great. But I would take you to the next page, the engage. Like from here is where you kind of want to read, get an understanding of how to go behind the lesson, right? So it says throughout this topic and the next topic, student will be providing theorems to help students keep organized. It's recommended that each student have a loose leaf ring with a hole punch note card. So you're getting it's walking you through some instructional implications that will help you and benefit you, the teacher. All right, and then let's look at the facilitation note. I will say, read it all. Read all of this thing. Let's say in this activity, the student recall the conjectures that vertical angles are congruent. Questions focus on proving that this conjecture is true for all pairs of vertical angles. Students review the angle addition postulate, linear pair postulate, and segment addition postulate. Great. You read that, but here's the next thing. It says, ask the student to read the introduction out loud. So It's giving you some instructional tips of what you need to do when you're getting ready to teach this. Have a student read it out loud, and then have students work with a partner or in group to complete question 1 through 4. Share response as a class. So you give a particular time. You say, okay, first, the student read it out loud. Then I'm gonna have y'all student in your table with your shoulder partner work for approximately 5 to 10 minutes, and then I'm gonna have a student come share. And then it says this: as the student are working, right? Let's say you give them 10 minutes to work. As they are working, as students work, look for the following. It says look for the use of vocabulary relating to lines, linear pairs, supplementary angles. Look for substitution of measures of the angle to make sense. So it kind of gives you some idea what you're looking for when the students are working. And then what questions to ask as they are working, right? So if you go to a group, ask them the following question: what is a linear pair of angles? What are the supplementary angles? So this is amazing instructional tips that kind of just walks you through your teaching rhythm, right? Like a pace of how you want to go through your lessons. This is some question you can ask during the group time, or you can ask this question as a student is sharing. You can always ask this question to the whole class. Furthermore, you can look at differentiation strategies, or you can see how can I differentiate from my students. Well, you get some ideas here. It says to assist all students, have them draw a diagram to represent each postulate and statement. And by doing that, they can do it individually, right? Or you can do it sitting with the pairs, however, but allows you to really differentiate and check for understanding. And goes furthermore by giving you some misconceptions the student might do. So some things that you can look for. Where can I anticipate mistakes from students? It says student may incorrectly assume that because the name angles addition postulate, they can add angles such as angle ABC plus angle C. See what I'm saying? Like those kind of things. Uh, we highly encourage teachers to read these bullets to get a better understanding, and it will help you with all the instruction tips and process and implication that you might do with the class. It will only make your classroom move as smoother as possible. And then you have a summary. Summary is more like how can you close the class. Postulate are one of the building blocks of Euclidean geometry. This question could just be asked. You can just ask students, can summarize your learning for today, or write a note to another student summarizing today's lesson, something like that. But those tips are here. And then keep in mind, like I said, if you don't end up using the lesson from Carnegie, you end up going with your own material. But that's fine. But just look at some instructional things that are listed here will help you. These are listed by activities. Okay, so you have activity 1.1 in lesson 1, same thing. Or if you go with activity 2 from lesson 1, which would be 1.2, you still have the same formality. You have your fact facilitation notes, question to ask, and then misconception, and then question to ask again. So you have all of those things that are listed for each of those activities. All right, I encourage you to go explore these resources. If you don't know how I got to it, just go back and rewatch this video. Thank you for watching this video, and I hope this is helpful.